Vamos iniciar nossa aula de telegrafia, hoje entrando em ditado, texto, porém, uma abordagem bem tranquila, vai bem devagar, bem pausado, né? Essas pausas aí bem tranquilas ainda. E aos poucos a gente vai acelerando, ok? Paulatinamente a gente vai subindo a velocidade, e somente em dezembro a gente vai entrar na velocidade que é referência, 125 caracteres em 5 minutos. Tranquilo? Então, agora, né, até dezembro, né, todas as aulas aí serão ditado, texto e aos pouquinhos subindo essa velocidade. Tá bom? Aos pouquinhos reduzindo pausas. Então, vamos lá. Primeira dica. Então, pega o seu caderno, pega a sua caneta. Para quem enxerga, segunda dica. Amigos deficientes visuais, lembrando, vai usar a sua visualização mental, ok? Então, o mais importante é você pegar primeiro os caracteres. Então, não se preocupe em tentar lembrar de frases, ou todo o texto, né, que você conseguiu aí totalmente ou parte interpretar, ok? Mesmo que você não consiga lembrar de tudo, né, formando as frases, tendo entendimento desse texto, não tem problema, ok? Então, isso é válido para os amigos deficientes visuais. Os demais amigos vão estar anotando, né, vai estar o texto ali na tua frente. Depois eu leio, né, todo esse texto aí para os amigos, tá bom? Então vamos lá. É um texto bem curto, tá? Ou coisa de 2 linhas só, tá bom? Bem lentamente, bem tranquilo. Observação: vem entrar as 26 letras do alfabeto, vão fazer parte também números de 1 a 0, tranquilo? Então se prepara aí, apostos, e 3, 2, 1. Corrigindo, ficou o seguinte. Bom, a gente vai dar um intervalo. E já a gente volta na segunda parte aí do ditado, fazendo a correção, ok? Então, em alguns minutos, 3 minutos mais ou menos, retornando.
L3 and high are the same thing, and L1 does nothing. So, but I'm pretty sure this is a 4-watt radio. And this battery is super old, but thanks for the radio, Dad. So that's pretty neat. It's, you know, I always want to know what my HTs are doing, you know, what they're capable of, because they're always advertised as something. Let's try this Islands HD1. This is supposed to be a 10-watt radio. We're on low power, you can see. Let's see what that gives us. 0.7 watts, which is actually good if you're trying to do DMR into a hotspot. We'll go to medium power. 2.5 watts. Not looking good. Again, this is supposed to be a 10-watt radio. High power. 6.59 out of a 10-watt radio. So there you go. So here's kind of my typical setup when I'm running HF. I don't have the dummy load hooked up in line because I have my setup. I've only got one HF antenna outside. So I basically feed the antenna to the antenna switch, and then I'll use the switches to go back and forth between different radios. So for example, I've only got one other radio hooked up right now, but it's going from here, into here, and then to this radio. So if I want to A-B something and compare different radios, all I have to do is throw this switch. Now you can see the waterfall is dead there because this radio is receiving now. I've got 2 extra ports. Now I can play with all kinds of stuff. If I want to kind of reverse it and have a bunch of different radios come into the dummy load, I would basically just reverse my configuration with the antenna switch and go to town, and I can hook up 4 different radios to the dummy load and kind of test things out that way. So pretty neat setup. So just real quick, wanted to show operating both of these radios through that. Everything's plugged in. So on 14652, I'm on high power. It's supposed to be a 50-watt radio. So let's key up real quick. 47 watts out. Okay, at MRD testing and clear. And you get to see your SWR, which is fantastic. Let's do that again. 1.12. So that's cool. Now all we have to do is flip our switch over on HF. Notice nothing happened over here. So I found a clear frequency in the CW band. So let's see, I'm on, this says 95%. So theoretically we'll get 95 watts out and we get 100. So thanks ICOM, that's awesome. And sun. So anyway, everyone, thanks so much for watching. I just wanted to share these toys with you because there's so many things in the amateur radio hobby that
Today on Ham Nation, Bob fires up an Amico. Gordo and George talk test equipment, solar updates with Don and Dr. T. Stay tuned. Ham Nation is next.
Netcasts you love.
From people you trust.
This is Twit.
This episode of Ham Nation is brought to you by ICOM. For more information, visit icomamerica.com/hamnation and by DX Engineering.
Quem perdeu alguns caracteres, aquela dica que eu sempre passo no curso, coloca um tracinho, ok? Perdeu uma letra, você põe um tracinho ali que você sabe que tem uma letra nesse ponto, tá bom? Perdeu mais para frente uma outra letra, né? Passa um tracinho. Tá? Mesmo na mesma palavra, né? Você pega ali 2, 3 letras que você não pegou, põe um tracinho, ok? Então vamos lá. Corrigindo ficou o seguinte. Vou dar uma lida bem lenta, ou bem lentamente, a segunda lida normal, tá bom? Então, corrigindo, atribui e destina faixas de radiofrequência ao serviço de radioamador e aprova o regulamento Papatango. Papatango, você vai aprender agora que é ponto, ok? A abreviação de ponto é Papatango. É isso aqui, ó. Tranquilo? Tem uma outra forma também, mas a gente pode usar aqui o Papatango, ok? Então, lendo mais uma vez o texto, quem perdeu algum caractere, vamos lá. Atribui e destina faixas de radiofrequência ao serviço de radioamador e aprova o regulamento. Ponto. Tranquilo? Mais ou menos. Não fica preocupado se você perder muitos caracteres. Faz as revisões, tá? Nesses caracteres que você está aí patinando, ok? Está perdendo a nota, né? Os caracteres. Vai nas gravações, cada aula tem ali 2 caracteres por aula. Refaz o treino. Isso ajuda muito, tranquilo? Nossos amigos deficientes visuais, mesmo esquema. Tá? Você vai interpretando cada caractere. Mesmo que você não consiga montar todo o texto, lembrar, não tem problema, ok? Porque o início, né, você está só iniciando a brincadeira, ou seja, né, só começando a criar as frases. Então, é normal, sua mente ainda não está preparada, ou, né, talvez até esteja conseguindo, na primeira aula, já montar aí, né, as palavras, o texto inteiro, ou ter todo o entendimento desse texto, né, como cada um, né, alguns vão ter um pouco mais de dificuldade, outros um pouco menos, tranquilo? O importante é não se apavorar, ir na boa aí no ditado, ok? A gente vai aos pouquinhos, né, trazendo aí mais texto, né, bem lentamente, até dezembro eu vou subindo a velocidade, vou reduzindo pausas, tranquilo? E você chega lá numa condição, no fim do curso, né, bem diferente do que está agora, ok? Pode ficar tranquilo. Bom, essa aula eu vou estar deixando aí na internet. Estou liberando agora para os amigos. Agora são 5h16. Lembrando que na segunda edição, 17h, repeteco dessa aula, ok? Hoje aula 21. Primeiro ditado bem light, bem tranquilo. Com pausas ainda bem grandes, ok? Intervalos aí bem generosos, tranquilo? À tarde, então, repeteco. Quem quiser ver um pouco antes, vai na playlist aula 21, tá bom? Entrou lá no nosso canal, no YouTube, coloca playlist CW aula 21 e boa sorte. Então, alguns minutos e já retornando. Bom, qual o nome do estudo? O estudo se chama plano de faixas, ok? Tá? Plano de faixas, que é igual a plano de bandas, que é igual a plano de comprimentos de onda, tá? Tudo isso é sinônimo, né? Faixa, banda ou comprimento de onda é a mesma coisa, ok? Mas vamos usar aqui a nomenclatura da Anatel. Tá? Plano de faixas, ok? Então está no anexo da legislação. E essa tabela está bem abaixo, tá? Vai correndo aí a legislação para baixo que você encontra aí. Plano de faixas, tabela B1. Tá bom? B3, melhor dizendo, né? Tabela B3. E a gente começa, né, o estudo dessas tabelas, faixa dos 2.200 metros. Tá? É uma faixa nova, né? A nova legislação trouxe essa nova banda para nós no Brasil, né? Totalmente novidade, made in Brasil, ok? Legal, né? Mais possibilidades, né? Quanto mais bandas, quanto mais possibilidades, é bom para a gente. Bom, então vamos lá, analisando faixa dos 2.200 metros, tá? Entenda que você tem a tabela na tua frente, dá uma olhada, da esquerda para a direita, né? Você tem ali frequências, tá? E outro referencial, né? Kilohertz, né? Você pode ter megahertz, você pode ter gigahertz, tá? Então presta atenção nessa nomenclatura, ok? Então tá ali, ó, faixa dos 2.200 metros, frequência em kilohertz, qual frequência? Olha lá, inicial, é o range, né? A gente já fala do range, tá bom? De quanto a quanto você vai usar nessa faixa dos 2.200 metros. Então, essa tabela é bem pequena, nós só tem uma possibilidade, de 135,7 a 137,8 kHz. Então, você vê que bem em cima está escrito, ó, inicial, final. Tá? Entenda o que significa isso, né? O que é inicial e final. Onde começa e onde termina. É meio óbvio, né? Mas é bom, né? Bom dar, martelar em cima aí, né? Chovendo molhado para não ficar nenhuma dúvida para os amigos. Bom, nesse range, né, o que você faz? Olha lá, tem um monte de opções. Tá? Só falando das opções, olha lá, CW, SSB, AM, FM, tá? Isso, modos analógicos. Tá? Para frente começa modos digitais. Então, DV, que é Digital Voice, modos digitais e demais modos permitidos, tá bom? Tá? Nessa faixa, o que você pode fazer lá? Tem um X. Tá? Onde tem um X é o que você pode fazer, tá bom? Se não tem nada, não pode, né, fazer. Tá? Então, o X é o que você pode fazer. Então, nessa banda, nesse range, né, de tanto a tanto, tá aí, ó, você pode fazer CW. Né? Você vai ver um X, né, em modo CW. Tá? Tranquilo. Né? SSB pode? Não. AM? Não. Frequência modulada? Não. DV também não pode. Lá, modo digitais pode, né? Tem um X, ok? Então, nesse X você pode, aí, modos digitais. Demais modos, não pode. Bom, a gente vai dar um intervalo, hoje analisando a banda de 2.200 metros. Sempre lembrando, esteja ou tenha a tabela aí no seu computador, ok? Tablet, celular. Celular eu diria que é muito pequenininho ali a tela, ok? É legal um monitor grande para você ter uma noção ampla, né, de todos os modos e o tamanho do range, ok? Mas cada um, então, fica à vontade aí do amigo. Tranquilo? Então, já retornando. Tá, então, resumidamente, na banda de 2.200 metros, nesse range, né, 135,7 a 137,8 kHz, só telegrafia e modos digitais, que é diferente do DV. Né, digital voice, né, voz digital não pode, né, modos digitais pode. Né, presta atenção que tem uma diferença, tá? E o DV não está incluso nos modos digitais. Né, tem uma divisão. Olha lá, DV não pode, mas modos digitais pode. Ok? E o modo digitais não abrange DV, né? Deixar bem claro, está separado na legislação da Anatel. Tá bom? Então, nessa banda, somente telegrafia e modos digitais. Ó, aplicações e observações, que é a última coluna. Tá? Tem lá uma nota, ó lá, nota 1. O que fala a nota 1? Então, a nota 1 fala o seguinte: a CDS pode ser utilizado com cautela, desde que não cause interferência em comunicações ponto a ponto e DX. Tá? As nomenclaturas a gente vai estudar mais para frente, tá? Senão fica muito comprida a explicação do plano de faixas, ok? Então, todas essas nomenclaturas, a gente vai ver tudo isso mais para frente, ok? Tem na legislação também a interpretação, né, de cada termo, de cada nomenclatura, né, mas isso é um capítulo à parte, senão fica muito extenso aí tudo que eu quero fazer, ok? Então fica aí só essa observação da nota 1, né, que está bem abaixo. Vamos falar da banda de 630 metros. Hoje analisando aí duas bandas, ok? A banda de 2.200 metros, que é novidade para nós, radioamadores, né, nessa nova legislação, que entrou em vigor aí, coisa de 1 ano e alguns meses, tá, 1 ano e 4 meses, mais ou menos. Tá, e essa é outra nova banda, ok? Então, dá uma olhada aí na sua tabela. É a faixa dos 630 metros. Olha lá. Tem lá a frequência, também em kHz, e o range, olha lá, inicial, final. Né, sempre lembrando que range é igual ao que está aí, ó, onde começa e onde termina. Tá, então, 630 metros, vai de 472 kHz a 479 kHz. Tá? Na sequência, olha lá. O que você pode fazer nesse segmento? O que você pode fazer nessa banda? Tá ali, ó. Tudo escrito claramente. CW, pode. SSB, não. Né? Não tá, não tem nenhum X ali, ó. Amplitude modular, também não. Frequência modulada, também não. DV, Digital Voice, também não. Mas, né, modos digitais pode. Tá vendo aí? Só duas possibilidades. Demais modos também não. E aplicações e observações, nota 1. Tá? Que é a mesma coisa que nós lemos lá em cima. Né? Nota 1 fala o seguinte: o ACDS pode ser utilizado com cautela, desde que não cause interferências em comunicações ponto a ponto e DX, DX, ok? Então, uma faixa de 630 metros, bem simples, né? Abriga em um único segmento, né? E duas possibilidades. Telegrafia e modos digitais, tranquilo? Bom, hoje a gente fica em duas bandas, tá? Que é 2.200 metros e 630 metros. Importante você olhar tudo isso, né? Ver todo esse padrão, né, de comportamento da subdivisão de cada banda, ok? A gente vai entrar em modos mais complexos. Então, só para te dar uma dica, né, a banda mais complexa é a banda de 2 metros. Tá? Exatamente aqui onde nos encontramos, ok? Por que é mais complexa? Porque aqui tem mais subdivisões, e cada subdivisão tem um monte de possibilidades. Tá? Uma única aula aí, só para falar de 2 metros, com certeza uns 20 minutos. Tranquilo. Você, né, realmente digerir, né, todo esse conteúdo, ok? Então, boa sorte, tá? Dá mais uma lida nas duas tabelas, nas duas bandas, tá? E bom entendimento aí dessa tabela que é essencial né, para o nosso objetivo, ok? Agora são 5h39. Lembrando que na segunda edição teremos um repeteco desse conteúdo de hoje, ok? Da primeira edição. Tanto aula de CW, comando de rodada e também legislação. Então tá aí. Quem acompanha a rodada alto-falante na internet, no YouTube, está vendo todo o processo de montagem de uma torre, ok? Desde o local, fazendo buraco, né? Etapa por etapa, bem minucioso, bem legal, né? É um baita referencial aí para quem quer saber um pouquinho mais do assunto ou pretende montar a sua torre, né? É um referencial bem interessante, tá bom? São 5h40. Oportunidade com um bom dia. Vamos lá. Resolução 449/2006, no seu artigo 73, nos remete às sanções. Tá? É um capítulo com um único artigo, ok? Porém, é um capítulo bem complexo pelo seguinte. Na legislação 449/2006, ele tem somente 2,5 linhas falando das sanções. Só que o segredo está aqui, ó. É uma outra lei, que é a Lei Geral das Telecomunicações, né? Tem 2 capítulos, cada capítulo com vários artigos, falando das penalizações para os radioamadores, ok? Então, se nós não formos cautelosos, a gente passa batido e nem sabe o que acontece, tá bom? Então, eu vou dar uma lida no artigo 73, tá? E depois a gente vai fazer menção à Lei Geral das Telecomunicações, ok? Que é o artigo 173 da LGT, tá bom? A gente vai falar dessa lei e eu vou também descrever, ok? Então, vamos lá. Quando a gente fala de sanções, fala de penalizações aplicadas aos radioamadores. Tá? Então, você pode fazer alguma coisa errada, né, branda, né, uma coisa leve, que a sanção vai ser, de repente, uma notificação, ok? Você aprontou alguma coisa, mas não é algo tão grave. Né? Exemplo, digamos, eu, né, estou na rodada alto-falante, e dá um surto aí, e eu começo falar palavrões, né? Imagina uma situação crítica que eu perca a cabeça, né, e começa a falar palavrões, xingar, enfim. E, né, alguém denuncia na Anatel e até mostra uma gravação, ok? A Anatel vai mandar uma notificação para mim. Olha, senhor Paulo, PY2EXU, recebemos aqui uma denúncia, né, que tal dia o senhor estava meio nervoso e, né, começou a xingar, a falar um monte de besteira e palavrões e tal. Então, o senhor toma a sua linha, né, fica mais tranquilo, né, o radioamadorismo, né, tem respeito, tem regulamentos, regras, parará, 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 e não passa disso, ok? Então, essa sanção, né, nesse exemplo que eu dei, né, é uma sanção bem branda, tá bom? É uma punição? É uma punição, né, mas não passa de uma notificação, ok? Então, vem um documento da Anatel, né, uma notificação informando que eu abusei, que eu extrapolei o bom senso, que eu fui um pouco mal educado, né, falando umas besteiras e palavrões. Só que não vem nenhuma multa, não vem nenhuma suspensão de atividade, que eles podem suspender, ok? Então é uma coisa mais branda, né? Ou qualquer outra coisa que eu fizesse de errado, porém, alguma coisa que não fosse tão grave, ok? Então seria uma sanção, né, numa escala hierárquica, de 1 a 10, nível 1. Tá? Bem branda, bem tranquila. Aí tem sanções nível 10. Então, uma sanção nível 10, você pode perder a licença, o quero, o indicativo, a cassação, né? Você pode ter uma multa, enfim, você pode ter vários problemas. Até um processo crime junto com tudo isso, ok? Bom, a gente vai dar um intervalo e já retornando na segunda parte aí do tema de hoje, sanções, ok? Sanções aos radioamadores. Artigo 73, resolução 449/2006. Então, alguns minutinhos e já retornando.
P40. Yeah, I've already read up on it. You guys know that because this is just another video in this series. So there it is, the SP40. And it's set up to be able to mount on either side of the radio, from what I understand. So we'll be trying that out, see about that magic sound that it makes. And then here's the radio. Somebody tore the plastic putting this radio in here, right here. So anyway, this doesn't really matter. Okay, so there it is. Well, this one may have been unpacked before. I think it might be a demo. And the reason I'm thinking as such is because, yeah, the tape has already been cut. And there's, yeah, I can see fingerprints on the display, and also there's no plastic cover that usually comes on the display, which is fine because that would have been really in my way. Okay, so bear with me a few minutes and I'll try, through the magic of editing, I'll try to speed up the setup process for you. Okay, here we are looking at the back of the radio. And so, yeah, since this one is a demo and has obviously been used before, the screws are over on this side. You can move them to the other side. See here? These screws hold the external speaker that comes with the radio. Basically $170 value. And so just going to, you know, let me show you. See the slots? So just going to line those up with the screws and let it slip down. There we go. So it stays on the radio. And then you've got a little plug here coming out of the speaker. And it's got a tie. There we go. And then it's going to plug. It doesn't have very far to go. It's going to plug in here, lower left, external speaker. So let's take a look at what else we have here. So this is the tuner or linear amplifier plug. Now on the FTDX10, these are separate. You have a 10 pin to go to a linear amplifier. You have an 8 pin to go to an antenna tuner. It's been combined on this radio, and I think maybe they just were running out of space. So you'll need to get a cable made for your particular tuner or linear amplifier. Now, fortunately for me, I'm using Elecraft, and a lot of the solid state amps these days are this way, where you have a built-in antenna tuner. And so all I need is the one cable anyway. And I have one coming from Elecraft. So I'll be able to try that out and use the amplifier. Here in the earlier videos, until that cable comes in, I won't be able to use the amplifier. But I'm going to focus mostly on the receiver side of this thing because, well, you know, they all transmit about the same. I'll let the lab guys test the transmitter for, you know, to see if there's any spurious radiations and things like that. But hey, you know what? It passed FCC type acceptance, so that should say a good bit about that. So there's your SO239 to plug the antenna in. This is the remote or ALC input. I don't use ALC with my amplifiers. Elecraft actually doesn't even recommend it. Here's the Morse key. And this time they've gone with the small jack instead of the 1/4 inch. And then this is the data connection. And then over here on this side, you've got 2 USBs. You've got the kind that will go like this one here is what I've got the, that's how it's connected to the computer for FT8. And then this one, you could put a mouse or a keyboard on. Now the FTDX10 has 2 of these. This one only has 1. Again, I guess, you know, they had to make room for that label. And then you have the DVI-D connector here to directly connect a monitor. And that's the same as with the FTDX10. And then, of course, here's your power. And I already have, since they're using a very common, oop, that's the wrong one. That's the one for my FT920. I'll have to get the other one. But I'm going to use my own cable so I don't have to use theirs. So let me get it powered up and we'll take a look. Okay, so let's let the smoke out. No, hopefully not. I'm going to long press the power button and, well, it wakes up. Oh, over here, it's just like the FTDX10. Power, tune for antenna tuner, Vox-Mox, you know, for voice operated transmitter or manually operated transmitter.
Essa é uma sanção bem pesada, né? Você perde o direito de falar no rádio, é caçado, né? Ainda paga uma multa e ainda vai ter uma dor de cabeça com processo crime, ok? Então, quando você fala de penalizações aos radioamadores, né, você tem que lembrar que essas penalizações têm graus para atingir você, ok? Então, da mais branda, né, nível 1, até a mais forte, nível 10, ok? Dando exemplo, né, de uma hierarquia na aplicação das penas, tá bom? Então, vamos lá, vamos dar uma lida no artigo 73. Lembrando, esse capítulo inteirinho, que consta de um único artigo, né, fala justamente dessas penalizações. Pode entender como castigos, como sanções aplicadas aos radioamadores, ok? Então, o artigo 73 diz o seguinte: a infração a esse regulamento, bem como a inobservância dos deveres decorrentes deste regulamento, sujeita os infratores às sanções aplicáveis pela Anatel, conforme definidas no livro 3, título 6 das sanções da Lei 9472/1997, bem como aquelas decorrentes de regulamentação expedida pela Anatel, ok? Então, você só leu, né, esse artigo, né, fez menção a uma outra lei, né, a Lei 9.472/97, e ficou nisso mesmo, né, não foi adiante. Tá? Aí que é o erro, né? Porque grande parte das penalizações pesadas estão aqui, ó, nessa lei, tanto, né, que é a Lei Geral das Telecomunicações, que é o nome conhecido aqui dessa lei. Tá? Primeiro que essa é uma lei federal, ok? Essa lei 9.472/97 é uma lei federal e a abrangência em todo o território nacional, ou seja, em todo o Brasil. A todos os radioamadores, PX, a todos que mexem com telecomunicações, tá? Essa é a lei máxima das telecomunicações, tá bom? É o marco, né? O marco das telecomunicações, essa legislação aqui, ó. Tá? Então, quem mexe com satélite, televisão, telefonia celular, tudo de radiocomunicação via radiofrequência, aí nas malhas aqui da Anatel, ok? Dessa legislação federal, tá bom? Então, o artigo 73, por si só, né, não fala muita coisa. Tudo bem, né? Fala das infrações do regulamento, né? Que nós, radioamadores, como essa legislação é para nós, que eu estou lendo, né? A resolução 449/2006, só para nós, radioamadores. Porém, ela nos remete para essa outra lei federal aqui. Essa, sim, é barra pesada, ok? Então, falando ainda do artigo 73, né, tá bem claro aqui, né, que todos nós temos que ter uma certa conduta na frequência. Tá? Então, educação, bom senso, né, não vai ficar contando piada muito pesada ali, né? Tem, às vezes, uma criança, tem uma esposa do lado. Tá? Então, até para as penas mais brandas, né, para as infrações mais brandas, melhor dizendo, você tem penalizações correspondentes. Como eu falei, né? Bom, a gente vai dar mais um intervalo e já retornando, ok? Hoje, lendo o artigo 73, resolução 449/2006. Hoje, entrando em sanções. As sanções são as penalizações ou castigo, né, para alguma coisa de errado que o radioamador faça, ok? E tudo isso tem níveis, então, do mais brando, como eu falei, a notificação, até o nível máximo ali que compreende multa, processo crime, extinção do hobby, ok? Perde a licença, perde COER, perde indicativo, né? E mais problemas que advêm dessa sanção, tá bom? Mas tem que aprontar, né? Não é de graça, né? Ninguém vai receber uma multa, uma sanção, né, no nível máximo à toa, né? Tem que ter ali um motivo grave, né? Ok? Então, já a gente prossegue. Então, lembrando, resolução 449/2006, artigo 73, sanções, tá bom? Então, em alguns minutos, na parte final aí do tema.
You might use often to the position where the roofing filter was. Now, I got to be honest with you, this has got a different DSP chip. I've got high hopes for it. This is as I mentioned in one of the previous videos, it has an NXP Semiconductors DSP chip, where most Yaesu radios in the past have used Texas Instruments. The DNF, that is auto notch in other terminology, in the FTDX10 introduces distortion. So that's one of the things I'll be checking out in this radio as well. I don't know how far I'll get in this video. It's an unboxing video. I don't want to get too deep. This is just some initial setup here. So I'm going to go into function and balance. See, it says AESS now right here. So the function knob is now adjusting AESS, and we're adjusting balance. We're determining how much we want to hear from the internal speaker, which is here, versus the external speaker, which is here. You can hear the low, I can hear, you may not be able to hear it, but I can hear the low frequencies coming out of the internal speaker. So just so you know, low frequencies are more omnidirectional. So it doesn't matter that the speaker is pointing straight up. Higher frequencies are directional, so they are coming out of this, the speaker on the right. That is a pretty cool sound. I wish you guys could hear that in stereo. I don't know, maybe if you're wearing headphones, you might be able to make that out, but I'm definitely hearing from both frequencies, both speakers, the different frequencies. I'm hearing the low content here and the high frequencies here. It's kind of a, wow, like a stereo effect or surround sound. So I have to find a signal and listen.
I'm concerned. Right here in Simpsonville, about 6 miles southeast of Greenville. And,
Wow.
Very near.
I definitely hear a lot of low end.
North of us is Travelers Rest.
I'm going to turn off the DNF.
And a spread of different cities.
Because the guy he sounds overdriven.
Being our nearest big one.
It may be that low end content. So let me go back in.
Got about an acre and a half. A lot of tall trees.
I didn't have to go back in because I'm already set on the ESS balance.
I used them for antennas. Over.
Okay, copy that. K2YN.
So we're determining here how much of this speaker we want to hear, the internal speaker.
My operating station here, I've got the radio.
I can definitely tell when I'm hearing only from this speaker.
It's a 160-meter loop, and I got the same big trees you got, I guess. Although we're all pine here. I'm in the sandhills of South Carolina, so we're all.
Okay. I'm going to turn off the notch.
But they're very tall. I mean, huge. Some of them have got to be 80 feet. And I got my 160-meter loop pulled up pretty well. I'm surrounded by trees.
Okay.
Got about one.
Yeah, see that wide notch is doing some of that muffling. I'm going to fix that right now.
We're in a neighborhood here where we have
just trusting it's in the same spot as it is on DX10.
Common area.
IF knots, look at there. First one wide. I'm going to go to narrow.
And then I got 4 neighbors here, so we're probably on a, I don't know.
Noise blanker rejection.
Everyone's got a lot where they put their.
We'll mess with that later. The yellow is the default, just like with the FTDX 10.
And then my 160-meter loop is fed with 300 ohm ladder lines.
Okay, now
down to I can't remember. I have the 1-to-1 balun or the 4-to-1 balun on right now with a little short piece of coax. And
if you long press this button here.
This area has a basement.
It says DSP reset. Long press, you'll get a beep, and it will turn off the changes you made in the DSP. So now we're not doing anything with DSP.
Here is the PAULO HF Auto and a LA1K.
Boy, he sounds good.
Amplifier.
Okay, let me tweak that AESS part again. Again, that's the default. So now I can just adjust it. Now I'm definitely hearing from the internal speaker.
Okay, very good. 350.
Yeah, this station just has a lot of low end anyway.
And I don't know what the limits are on those.
Now I just turned off the internal speaker, essentially.
Pretty sure it's semiconductor. That
I'm going to leave it on 75%. That seems to be
running a bit more
a decent balance.
Here. We're doing about 1,400 on peaks. We keep it held back a hair. But it's
I hope you can hear me in the video explaining things. I may have them too loud. I don't know. It's hard to gauge. Hopefully you can get something out of it. It's very difficult to reshoot these because once they're loaded up, YouTube doesn't allow any editing. You just have to completely start over. Okay, so this button here is where you determine the cutoff frequency for the internal speaker. So it's either 700 hertz or 1000. So what we're saying is now I just tuned it, set it to 1000. So we're saying now that 1000 hertz and lower will go to the internal speaker. Just adjust it to where it sounds good to you. Now, I have some viewers who have mentioned to me that they're hearing impaired. And so, how our radio sounds for them on receive makes a difference in whether they can use it or not. So that's going to give you some, a little bit of opportunity to tweak this to sound good to you. And I'm going to toggle back and forth with this station that's not so, it doesn't have so much low content in his voice.
But I noticed, just because your voice sounds natural there, and
É uma notificação, sem multa, sem apreensão de equipamentos, sem nenhum processo crime, sem nenhum tipo de isenção, né, de frequência, sem ficar fora do rádio por 1 ano, 2, ou perder, né, o COER, a licença, ou ter o documento cassado, né, da sua licença, enfim. Então, essas penalizações podem acontecer, né, das mais brandas às mais pesadas, ok? Então, tá aqui, ó. Essa sanção, né, do artigo 173 em diante, que é da Lei Geral de Telecomunicações, a gente não vai ver hoje, tá bom? A gente vai dar uma olhada nela amanhã, ok? Hoje só vou dar uma lida aqui no artigo 73, né, que fala das sanções, e amanhã a gente vai para a Lei Geral das Telecomunicações, tá bom? Assim a gente vai ficar aí uma semana pelo menos. Tá? Todo dia vai ter artigo para a gente ficar lendo, explicando, né, as sanções, as penalizações. Você tem 2 capítulos, sanções para nós radioamadores, ok? E 2, né, sanções para quem não é radioamador. Eles consideram estações clandestinas. Tá? Então, quem não tem a licença da Anatel, não tem o COER, não tem indicativo, a lei considera clandestino, ok? E é crime, tá bom? Mas a gente fala dessas penalizações, sanções da Lei Geral das Telecomunicações, tranquilo? A gente fica aqui só no artigo 73 e fazendo menção da Lei 9.472/97, tá aqui, ó. Tranquilo? Então, por hoje é só. Vou liberar aqui essa primeira parte da gravação. Ok. A gente vai entrar realmente numa lei federal. Essa nossa lei é uma lei federal também, porém, é uma resolução. Então, uma resolução abrange todo o território nacional, é uma lei que abrange todos os radioamadores do Brasil, e a outra lei, que a gente entra amanhã, também é uma lei de abrangência nacional, porém, é uma lei. Né? A lei é mais do que uma norma de pequena hierarquia, ok? Ou de baixa hierarquia, né? Como resoluções, como decretos, portarias, normas, atos. Né? Uma lei já subentende-se uma hierarquia maior, tá bom? Bom, são 6h13. Lembrando que já tivemos aula de CW, hoje aula 21. Na segunda edição, repeteco dessa aula, ok? Quem perdeu pode ter essa mesma aula lá na playlist, entrar lá no YouTube, CW e aula 21, ok? Ou segunda edição, 17 horas em diante, esse mesmíssimo conteúdo. Então, vou dar um intervalo aí para os amigos e já retornando.
Kind of balancing one another out, but it is going to be very sensitive, and on these lower frequencies, even intercept point optimization might not be enough. Uh-oh, somebody's off frequency.
So now we got one on 89, then we got another one on 92.
So I'm going to engage 6 dB of attenuation. Now I'm gonna level with you on the DX10, FTDX10. I run on this band. I run IPO and 6 dB of attenuation. That's just my standard.
Throw it in the iron skillet there, right? That's pretty wide there on 92. You know they hear the splatter.
Okay. That's only 1 kilohertz away. You're not going to knock that out. But remember, this radio is third in the world now for being able to do, to being able to block interference from 2 kilohertz away.
All right, buddy.
And by the way, the test is run on CW, so don't get too excited and think you can do that on sideband.
Have a good day. Kilo Juliet 4, Romeo Echo Zulu, 73. Yeah, I'm going to get out of here.
And I know some of you want me to compare this to the FTDX10. I'll get around to doing that. This is going to be a long series, but let's not try to do comparisons just yet. I can tell you right now, based upon what Rob Sherwood's numbers are, they're going to be neck to neck. The FTDX10 seems to have an edge when it comes to interference coming from 100 kilohertz away. Or just imagine like you got a neighbor and they're on a different band, and you're on, let's say you're on 40 meters and they're on 20 meters. The FTDX10 is going to have a better number as far as rejecting the interference from the other band. In that category, it's 141 dB dynamic range versus 129 for this. The FTDX 101 rules on that one at 147 dB. Again, that's for blocking interference from 100 kilohertz away. That's actually about one of the only numbers this thing really was inferior on as far as the FTDX10. But by the way, it's still a good number. I mean, this radio is in the top 10. It's number 3, as I've explained in previous videos. So if you go to Sherwood's list and you see it in number 4, read the footnote for the number 2 radio, read footnote Y. I've covered that in previous videos, so I won't do it here. Low frequency.
A bunch of D104 heads, and I've got, let's say, 1, 2,
So
3,
just
4, 5,
to reiterate what I've done in this video, of course, power the radio up. And you know me, I like to cut the grass. As far as the scope is concerned, let me explain. I'm going to change the color pattern here, or color to the one that I use when I say cutting the grass. There we go. Where you got the green. And I set the level. Now, see, on the FTDX10, you have the advantage of that outer ring, which I leave set because you got that C.S button, custom switch. And I leave that on C.S. I leave the C.S set for level, so I can just reach up and grab the ring. That was the ionoson going across, checking propagation. I leave the outer ring on the FTDX10 set for level, so I can quickly go up there and adjust this, because if you change IPO and attenuation settings, that's going to affect the level coming into the scope. Think of it as scope sensitivity, even though it says level. So see, like, what's this? I don't want to see all that. That's noise. I only want to see the signal spike. So I'm going to cut the grass. See, that's beginning to look better. I don't want to go so low that I can't see a weak signal, but I definitely want to get rid of the noise. So I call that cutting the grass. See, it fades to blue. That looks pretty cool. So there you learned something else in the menu, a little bonus there on the video. I'm going to change this one too, the level, the peak. I like 4 or 5, and I'll tell you why. If you look, see what it's doing, brighten it up a little bit. Well, you can actually see a little white spike, like especially in CW. You see a little white spike, which is live. The rest of this is memory, okay? There's an old saying from my youth. There was a company called Memorex that made tapes for recording, and the commercial was, is it live or is it Memorex? Well, in the background, what you see going toward the back, that's a memory. That's history. Think of it as history. That's already happened. But in the foreground, by setting the peak the way I just did, 4 or 5 will do it. You're now, it accentuates the live portion with a white spike. Just makes it a little easier to see. Certain color settings, it'll be less noticeable. I have found that in the factory default, which is color 5 and color 10, it's easier to see. And it's even better if you've got it displayed up on an external monitor. And do remember, let me just say this out of the gate, so to protect you from any damage, try to get, if you're going to do an external monitor, try to use what's called a DVI-D monitor. I know they're a little harder to find now, but the resolution the radio puts out to a monitor, it really doesn't need HDMI. It probably would have saved them some space on the back of the radio to go with HDMI, but there's some licensing involved. I personally think, and I've been shot down about this, but I'll just say it again. I personally believe that Yaesu got a good deal on a bunch of DV-ID connectors, and that's why they went with it, and it saves us money in the purchase price. So I'm okay with that. I happen to have had an old DV-ID monitor in the closet, and that's what you've seen in all my FTDX10 videos. If you go out and try to get an adapter that will convert DV-ID out of the radio over to HDMI for your monitor, you run the risk of damaging the radio, and there have been many of them sent back for warranty repair as a result of that. So just avoid having to be without your radio while it goes to Yaesu and gets repaired. Try to find, I don't know, and last time I looked, they were available on Amazon and eBay, an actual DVI-D monitor. So think of it this way. You want a cable that looks the same on both ends with no adapter in the middle. Do yourself a favor there. But this screen is a little bit smaller than the FTDX10 display. In the next video, I'll actually put them put one on top of the other so you can get an idea of the difference in size. It's definitely a significant difference. But anyway, so that having an external display, it will be even more appreciated with this screen. You will be able to see things a little better. But I tell you, that's not bad. That is not bad. Okay, so again, recap. Unboxed it, let the smoke out. Fortunately, there was none. And did some initial settings. Of course, I'm just operating off the VFO right now. It does have band stacking. And for those of you with an FTDX10, it works just like the FTDX10 band stacking works in the later versions. My FTDX10 is running firmware V0104, and it works in the sense that you just double tap the band button to cycle through the band stacking. With this radio, I read them in the manual. It works the same way as FTDX10. You will press the band button, and I'll go ahead and do one here. Band. Hello, N4HNH here. Well, today's video is going to be somewhat somber, sad. We're saying goodbye to an old friend, the Yaesu FTDX3000. I never owned one, but I seriously considered one before I bought my FTDX5000. It's a fine radio, that 3000. Wow. And Yaesu announced last week that they will discontinue manufacturing this radio. And I actually had a conversation this morning with the marketing manager, and apparently it's a supply chain issue, the availability of some of the key components. And well, I don't know if you guys have heard about this, but they've had some, there's a factory that has burned to the ground in Japan that was making some of the components primarily for Kenwood and ICOM. In fact, the Kenwood THD74 HT is also going to be discontinued, and apparently, from what I've read, it has to do with that same factory in Japan. I don't know if that's the case here with the the marketing manager didn't say that the parts for this radio comes from that factory. He just said there are some supply chain issues, and they don't like to continue making a radio if they don't feel like they can support it for 5 years. So the way I understood it was they want to be sure that not only can they get enough parts to build a radio, but if they were to stop building it, they would have enough parts to support repairs for 5 years. So apparently they don't feel confident that they will be able to maintain support for the 3000. So I spoke with HRO this morning, and they have 17 of these in stock nationwide. So if any of you were considering getting a radio in this class, I would highly recommend jumping on the chance. And which is going to lead to part of what this video is going to be about. But I just wanted to make that announcement. Now, it was also announced by someone in the past week that the FTDX5000 was also being discontinued. My pal here. But according to Yaesu's marketing manager this morning, he said, so far, so good with this one as far as the supply chain, but they are keeping an eye on the situation. You know, COVID has caused some hardships, and then sometimes it's just a matter of, you know, some key component. I remember some years ago, one of the things they mentioned that might cause the demise of the FT857D was the availability of the VFO knob. But somehow it still hung in there for a few more years. Sad though, because, and I get on Yaesu a little bit about this. They will discontinue a product without having anything comparable to put in its place. You know, for example, the FT270R, which is one of my favorite handy talkies of all time. Waterproof, mil-spec. I like that the microphone screws in at the top, so I can put it in a case, and you know, it's no problem to get a mic plugged into it. And has a tremendous receiver on it. It's a single band, you know, and that's what I wanted. You know, I hike these mountains for summits on the air, and a lot of times we're around towers. We have one here in Atlanta, Stone Mountain, and there's a 50,000 watt broadcast transmitter up there. Most radios you go up there with can't hear, even other Yaesus. Not the FT60, I will say. It works pretty well up there, and that's one I hope they don't discontinue anytime soon as well. But the radios that are SDR based or direct conversion, even the Yaesu FT65, of course, a Baofeng, they're stone cold deaf up there. They're deaf as a post. But the FT270, I can stand up there under the tower and with 5 watts, and I can have a QSO with somebody 60 miles away. I've done it. But it got discontinued and no replacement. So nothing in that, you know, $150 price range. And now you might wonder, well, Doug, why would you want them to hold on to older technology? Because it was single band, super heterodyne, a dual super heterodyne. Well, see, this is what I want to talk to you about. We got to be careful what we buy, because what we buy is signaling the manufacturers what we're willing to pay for, therefore what they're going to make. And sorry, I sipped some coffee. The issue is, so the introduction of the SDR, software defined radio. Well, that's the new buzzword, right? It's got to be great. It's the newest technology. The truth of that is, I'm just going to be straight with you guys. It's cheaper to make a radio using a software-defined radio because it's on a chip. It's cheaper to make the radio. As a matter of fact, the size of the radios can be smaller than they are. They've got to fit a screen, a few knobs on there. That does not necessarily make it better. As a matter of fact, it gives them maybe a better margin on the manufacturing side, unless they're willing to invest in the proper filtering in the front end of that software-defined radio, so that it can compete with a super heterodyne. So don't get the idea that, software-defined, it must be better than super heterodyne. That's not necessarily the case. Now, credit where credit's due. Flex has done software-defined radio right. They put the proper filtering in there. But look what you pay for a Flex. When the 7300 came out, and a friend of mine had one, and we were noticing the front end overload issues and terrible selectivity, and I said, well, you know what needs to happen? Well, let me explain why that is. Okay, so when you're directly sampling off the air, you're dragging in everything out there. You know that your antenna is capable, all the magnetic waves your antenna is capable of trapping. DC to daylight. Okay, I mean, it's like. This brings up another point. You look at the specs of an HT, for example, and it'll say, wow, it can hear AM broadcast, it can hear FM broadcast, it can hear aircraft, it can hear 900 megahertz. And by the way, it happens to also work on 2 meters and 70 centimeters. So you read a spec, and they know this about us, the manufacturers, the marketing people. You read that spec and you go, wow, that thing must be incredible. No, we got to be shrewd. We got to know what we're looking at there. When a radio has a front end that's open to that many different frequency ranges, it's got a front end that's going to drag in all these things you don't want to hear, and it will serve to work against the selectivity aspects of your radio. Selectivity meaning the radio's ability to hear what you want to hear and reject the signals you don't want to hear. So see, to me, two very important things about a radio receiver are selectivity and noise floor, signal to noise ratio, which is why I chose the radio you're looking at. If you know my story, I think I've shared it in maybe a video or two, but I went into ham radio outlet in January of 2019, having saved up to buy a Kenwood TS990S, my dream rig. And before I walked out, I looked over and I saw an FTDX 5000 sitting there, and I thought, I guess it'd be prudent to at least give that radio a listen. I picked out this CW signal. There was an S6 noise floor down there. It's a terrible location, industrial park area there. Our ham radio outlet is located in.
Agora são 6h31. E a gente lembra os amigos de alguns eventos aí no final de semana, ok? No domingo. Então, temos aí Ermelino Matarazzo, domingo sim, domingo não. Tivemos aí no dia 16, ok? Domingo passado. E agora, dia 30, tá bom? No outro domingo. Então, depois de amanhã não teremos, tá? Mas no outro fim de semana teremos Ermelino Matarazzo. Para quem não conhece o endereço, anota aí. Vamos passar esse endereço, ok? Parque Municipal, Ermelino Matarazzo, Rua Abel Tavares, 1542. Rua Abel Tavares, primo, quinto, quarto, segundo. Então, importante, domingo sim, domingo não. Tivemos aí dia 16, depois de amanhã não teremos, e só no outro domingo, dia 30/10, tranquilo? Também Pacaembu. Pacaembu, toda segunda-feira à noite, às 19h30 em diante. Lembrando que esses eventos são para todos, ok? Corujas, PX, simpatizantes do hobby, futuros radioamadores e radioamadores com certeza, né? Todos podem comparecer, nenhum problema, tá bom? Então tá aí, fica aí a dica dos dois eventos. E quem tiver mais algum evento aí ocorrendo, Zona Norte, Sul, Leste, Oeste, ABCD, Interior, Litoral, passa pra gente, eu divulgo, tá bom? E vamos em frente. Oportunidade com bom dia.
Saying. So let's not get caught up in newest technology must be better. It's better for the manufacturers because they can build the radio cheaper. Again, if they want to do SDR right, they've got to put some proper filtering in the front end. So back to, I was playing with my friend's 7300, and I was saying to him, somebody needs to come out with a SDR. I get it. It's a good idea, but somebody needs to come out with one where you've got a traditional front end that can filter the signals down to what I want to hear, the band I want to hear. I don't want to hear DC to daylight coming in my receiver, and then I got to sort through all that. I say the radio's got to deal with all that extra coming into the front end of it, and I'm just wanting to hear the ham band, right? So, excuse me, another sip of coffee. I told him, I was saying, to my friend, I think I even told my brother this. Somebody needs to come up with a radio that's got a traditional front end and then hand off over to the digital world. And within a year or so, I saw the block diagram for the Yaesu FTDX 101, and I was amazed. There it is, the hybrid. You got the best of both worlds. And the 101 is a fine radio, don't get me wrong, but I still prefer a super heterodyne. I believe the radio you're looking at right there, the FTDX 5000 MP. In all of my years, I've been involved with radio since I was 14, and I guess I'll just tell you I'm pushing 60. I've worked on them for a living. focused primarily on HTs when I was younger, the Motorola HTs. But I want to tell you, I think this radio that you're looking at is the pinnacle.
Hello interwebs, welcome to Let's Fix Computers. I've got an Asus Chromebook here. This is a C433T Chromebook, and it's been liquid damaged. And then seeing where we stand. Let's see. Firstly, let's just see if what screamingly obvious short circuits we have. So I will put the multimeter into resistance mode, and I'll put one probe on ground, and let's just start having a look around here. So this capacitor is almost certainly burnt out. Right, so we've got what looks like ground, and on the other side, open. What about this guy next to it? Open as well. Okay. Just going to have a quick dig through all of this horridness here. Kilo ohms as well. You know, it's hard to tell. Ah, there we go. If I get right down underneath that capacitor, then we've got our short circuit. So yeah, this rail is shorted, whatever this is doing. We need to look up what that chip is to find out. If we see what that's powering, hard to tell. So there's a short circuit there. Then down here, this is backlight power coming down here. So this is almost certainly shorted out as well. Again, we'll go black probe onto a screw hole, and we'll just have a quick poke down here. So, yeah, that is ground, and the other side. Oh, I lied. That's our ground plane anyway there. So it's this side that we need to be not shorted. Oh, it's hard to tell. There's so much guff in there that it's difficult to get a good connection. No, I don't think that's shorted. Okay. This probably just looks angry because there was a lot of power there. This guy up here. It's hard to even see where the edge of that chip is. Yeah, that guy's not shorted either. So there's a lot of corrosion around here, but not an actual fault, which is good. What about this stuff here? That's ground. Other side is not ground, so that guy's okay as well. And this MOSFET down here, let's just go onto the back of these capacitors. There is a bit of a conformal coating, as there tends to be with motherboards. Yeah, that's not shorted. The other side will probably be ground. Yeah. All right, so all of these areas here, they look really upset and angry, but there's no short circuits there. Now, that doesn't mean there's no problem, but it's certainly a good sign. And again, if we travel up here, we do have a short circuit in this area. So maybe there's a good chance that if we clear that short circuit, we'll actually be okay. So what I might do is just clear that and see if it switches on. I might just do a little bit of brushy down there just to get the worst of that corrosion off as well, and then we'll go from there. But yeah, let's get the motherboard out of this thing. So we'll pop all the connections out. I shall undo the screws, and we will release this boy, and then we can get to the soldering rework.
And welcome back to our third part of our SMPS series. Today we're gonna really repair our SMPS power supply, which we have start. So first what we really can do is check if our AC is present at the input terminals. And you see the input terminals down there. So I have to work around the camera, which is a little bit more complicated, but I hope I will be able to do it. So let's try. Not really. Not really. Okay. So now I'm here down at the terminals, and you see we have 232. So that is fine, no problem. The next, what we really should check is, so let me go a little bit closer here. So since we have a two-phase main switch here, so let's check if we can get it a little bit better into view. So we should check, I mean, no, it is not switched on. So let me switch it on. Now the main switch is on, and we should get, let me see if we can see here at least a little bit. And let me see if our mains is getting through our switch. Come on, what's going on here? How is it done? Let me see first. Maybe that I need to check first if how the switch is working. So let's see. Is it? Okay. So it is working this way here. All right, got it. So that means mains is switching through. So that is a little bit funny. Not sure. Okay, so let me do first testing the switch with the Ohmmeter, with the beeper, to be sure how it is really done. Otherwise, we cannot be sure how it works, and I'm not able to get here to this contacts as they are protected. I mean, that is a good thing, and we will definitely see it here a little bit more often, that we really have problems to get to all the test points, since it is really nicely done, but we need, I believe we really need to get the PCB out of the chassis to be finally able to get to all test points. But before we do that, I try to do everything what's possible here directly with the PCB in the chassis. All right. Okay, so here we can see it. So switch is switched in. So that is the first line, and that is the second one. So you see both are working, and when I switch it off, then of course we do not have here contact in any way. Back switching it in, and you see resistance is 0.05, which is fine on both sides. So we can say our switch is fine. That means that is definitely not the problem. And next step, we test our fuse. I've already taken the plastic here, the protection away. And I have taken, as you hopefully can see, the fuse a little bit up so that it is not in circuit, not that I'm testing here a short maybe. So
Agora são 6h45. E a gente lembra os amigos, estamos aí com 2 campanhas em andamento. Campanha de doação de sangue, que já vem com a rodada alto-falante há muitos e muitos anos, ok? E campanha do agasalho. Então, ainda temos aí noites, manhãs, tardes, né, bem frias. Quem puder colaborar, tem aquelas caixas de papelão em supermercados, farmácias, repartições públicas, enfim. Colabore, ok? Uma blusa, uma roupa que você não usa mais, em bom estado, dá uma lavadinha, põe num saco plástico e colabore, tá bom? E a campanha de doação de sangue também. São vários hemocentros, vários pontos aí que você pode colaborar e salvar uma vida, ok? Então, não deixe por menos, faça aí a sua parte, colabore. Lembrando que radioamadorismo é uma prestação de serviço público também, ok? Não só o nosso hobby, mas ajudando a comunidade, a sua cidade, tá bom? Outra coisa, mudando aí de alhos para bugalhos, já tivemos a nossa aula de CW. Quem perdeu a aula 21, ok? Na segunda edição vai ter um repeteco dessa aula, ou na playlist. Entrou no YouTube, vai em rodada alto-falante, e tem uma playlist. Cada playlist é um curso aí diferenciado, tá bom? E boa sorte. Qualquer dúvida, dá um alô pra gente via radiofrequência ou na live aí no YouTube via internet. E vamos em frente. Oportunidade com um bom dia.
which is then already our DC high voltage side. And that is, of course, what we can measure, what we can test with our multimeter. So normally I would try to get to the bridge rectifier here.
We're going to take a close look at this RigExpert AA55 Zoom antenna analyzer, really kind of geared towards the radio amateur who likes operating in HF and the 6 meter frequency bands. Because the 55 stands for 55 megahertz, which is the upper frequency range of this analyzer. RigExpert makes about 10 different models of analyzers that range from a max frequency of 30 megahertz up to 1400 megahertz, or 1.4 gigahertz. We should more accurately call this unit a multifunction antenna and cable analyzer because it really is a lot more than simply an antenna analyzer. Let's go take a look at what I mean by that. I'll do a quick rundown of the various measurements you can make with this AA55 Zoom. We've got the ability to plot the complex impedance versus frequency on a Smith chart, as well as plotting SWR versus frequency on a traditional SWR sweep. Plot just complex impedance versus frequency, the real and reactive components. The SWR meter is a single frequency SWR meter that has a couple of interesting modes in it. All params is a way of looking at everything from the SWR, return loss, complex impedance, etc. at a given frequency. The setup function allows you to go in and set up the language, the units, whether you want it to be imperial units or metric units, set up frequency bands, amateur radio frequency bands to be in the Americas or Europe and other parts of the world. There's a calibrate function that allows you to do a full vector calibration so that you can establish a reference plane either at the instrument's connector or maybe at the end of a piece of coax. So you can actually make measurements referred to the antenna feed point impedance. You can also sweep return loss versus frequency. The multi-SWR function allows you to measure SWR at multiple frequencies, really handy when you're trying to tune a multi-band antenna and looking for the interaction between tuning one band and seeing its reaction on another band. And there are some additional tools for coax measurements which can be really handy. A stub tuner that allows you to tune or to measure and tune particular lengths for quarter wave and a half wavelength long hunks of coax or stubs of coax. You can also measure the length and velocity factor of coax, and also sweep the cable loss and cable impedance versus frequency. So lots of functionality and actually very easy to use. If you take a look at the icons here on the left-hand side, the number is associated with the keypad number. So for the Smith chart, we would just hit number 2, and you see that key number 2 says polar, and that's essentially the Smith chart. If you want to do an SWR chart, you could just hit the number 4, and it says SWR right there. The real and imaginary impedance plot is key number 5, etc. So it's very, very easy to figure out what to do. And also, no matter where you are in a measurement or things like that, the 1 key is generally a help key, and it tells you so right here. If you hit 1, it actually gives you help, and you can scroll through and get help about what these various keys do. So you don't even have to crack the manual open, even though the manual is actually very well written. I've got access to a 20-meter antenna down here in the basement shack, so let me hook that up to the analyzer here, and we'll run through some of the measurements that we can make on this antenna. Let's start off with the very basic SWR chart. So I'll select that by either hitting 4 or arrowing up and down until I select that item and hitting OK. And right now I've got it set to sweep with a center frequency of 27.5 megahertz and a sweep 27.5 on either side. So it's the full range sweep. And if I hit OK, we're sweeping that full range of the antenna. Now what you can see on this sweep are these various colored bands. Each of these colored blue bars represent amateur radio bands. In this case, I've got it set for the US and North America amateur radio bands. And we can actually see we've got a dip in the SWR right here on this band, which happens to be the 20-meter band. In fact, the minimum is being shown here at about 14,360, just outside the amateur radio band, about 1.89. Now, any of the plots that are made on the analyzer itself consist of just 100 points. So it's likely that there's a lot more going on in here. Now, we can tune the analyzer a number of different ways. Just by hitting the frequency up and down keys, I can shift our measurement frequency. And then the up and down keys here will change the range. So I can zoom in on a particular area. So I can center that again and zoom in again. And then I can go and repeat the measurement and do another 100-point sweep right there. So now I can actually see I've got a little bit better granularity in the 20-meter band, and I can actually see that the minimum is sitting inside the 20-meter band. Just as an example of some of the other functions that are available to you, we'll hit the help key here. So you can do, you just have it run once and stop by hitting the check like we've been doing. If we hit the function and checkbox, it'll continuously cycle and continue running until we hit the stop key. 0 will show the data at the cursors, and I'll show you what I mean by that. So I've got the cursor.
Agora são 6 horas e 53 minutos. A gente dá bom dia para os amigos que chegaram na frequência. Nosso amigo Cabral, grande abraço, hein, Cabral? Tudo de bom. Nosso amigo Manuel, PY2 Juliette Mike Papa, também grande abraço, obrigado pelos votos. E o nosso amigo Ian, Foxtrot 4, Whisky Delta Victor, lá pela França, em Montpellier, diretamente dos Alpes suíços, olha lá, 1.580 metros de altitude, hein? 10 graus, tá mais frio que aqui, viu, Ian? Bom, nós tivemos aí 8 graus, 7, hoje, agora com 19 graus. Tá, comecei a rodada, estava 17, 18 e agora 19 graus. Mas tá bom. Tudo em paz por aí? Tranquilo? Então, maravilha. Aqui também tá tudo bem, hein? Família tá boa e a gente também com saúde é o que importa, né, Ian? Manuel, Cabral e amigos. E todos aí pela internet, todos via radiofrequência. Lembrando, já tivemos aula de CW. Quem perdeu a aula 21, ok? CW aula 21, pega lá na playlist, ou segunda edição, 17 horas, o mesmo conteúdo, ok? Lembrando que final de dezembro finalizam os 3 cursos: CW, comando de rodada e legislação. Então, quem pretende fazer com a gente em janeiro, iniciando aí os 3 cursos na sequência, ok? Boa sorte, qualquer dúvida, dá um alô pra gente. E vamos em frente. Quem está vendo a live está vendo um aparelhinho bem legal, ok? Um dos últimos analisadores que foram lançados, o Rig Expert, totalmente digital, ok? E para comparar, né, tem ao fundo um MFJ totalmente analógico. Olha o tamanho de um, o tamanho do outro. Isso que ele está bem para o fundo, né? Se fizer um do lado do outro, né, esse analisador digital é 1/4 do tamanho e metade da espessura, ok? Muito moderno, né? Hoje os analisadores digitais dão um show, né, nos analógicos mais antigos. São bons, com certeza, né? Mas olha o tamanho de um, o tamanho do outro. A gente está vendo que a coisa vai evoluindo, né? Fora os moderninhos, né, chineses também. Tem vários, né? Várias marcas aí no planeta. Essa é uma das opções, tá bom? Que painelzinho bacana, né? Bom, oportunidade aos amigos com um bom dia.
Change the scale of the measurement that we're looking at here. Instead of being plus or minus 1,000 ohms, we can knock that down to look at even a finer scale, to look at the real and imaginary components of the complex impedance looking into this coax. The function 4 key will take us from the SWR plot to the return loss plot, just another representation of essentially impedance match. And essentially we want the return loss to be as high as possible when the SWR is low as possible. So we can actually see we get a return loss here of about 15 or so, 14.8 at 14.24 megahertz. So those 4 measurements, the Smith chart, SWR return loss, and complex impedance sweeps, are all kind of the swept measurements that you can make with this antenna analyzer. But there's a number of other measurements we can make which are equally useful. So if we hit the 7 key, or the SWR key, we'll get essentially a SWR meter. And by hitting the OK checkmark key here, we can start the meter reading. That's what the flashing indicator means here. And this shows us our measurement frequency, graphically and numerically showing the SWR, as well as showing the return loss. Again, I can hit the frequency keys to move up and down in frequency and see how the SWR changes at different frequencies. And if I use the function and arrow keys, we can move the frequency in larger steps. And of course, hitting the frequency and range key, we can actually dial in a frequency directly if we want to do that. But there's some other interesting capability here. Let's take a look at the help key and see what I'm talking about. So we talked about how to change frequency and set frequency, start and stop the meter. But there's also this function here called SWR to air. This is actually a very interesting feature. Let's look at that right now. The SWR to air feature is really useful when the analyzer is sitting in a spot where you can't see it when you're making adjustments on the antenna. It could be that the analyzer is sitting at the end of a coax, maybe inside your vehicle or inside your Radio Shack, and you're outside making physical adjustments to the antenna, and you can't see what the meter reading is saying. So the SWR to air function basically will transmit a code to tell you what is going on with the SWR as you're making adjustments to your antenna. You set the SWR to air transmit frequency using the function 3 key, and then you start this up. Let me show you what that looks like. Now, I've already set the SWR to air transmit frequency to 144.500 megahertz, so I can hear it on this little handy talkie. So I could stick this thing in my back pocket when I'm making adjustments to the antenna. And then in order to enable this function, I hit the function and checkmark key. So let's actually go do that. So I hit the function and checkmark. You hear one short beep coming out of the radio. So the single beep tells us that we're in the 1 to 0.0 to 1.99 SWR range. As we go higher in SWR, the duration of that beep gets longer. So we can hear now that we're at 1.76, 1.77, 1.8. The length of that beep is longer than it was down here. So it's a nice short beep now that we're below 1.5 to 1. If we go even higher in frequency, we get into the 2s. It's transmitting 2 beeps. Okay. We get into the 3s and above, it transmits 3 or 4 beeps to tell us that we're way out in SWR. So by listening to these beeps and how many are being transmitted and then the duration of them, we can see how our SWR is doing remotely without having to actually be seeing what the meter is doing. Now, another handy feature for the single frequency SWR measurement is the heartbeat display. And that display is entered by hitting the function and up arrow. So if I hit the function up arrow here, we get this heartbeat display. And what this is kind of like a scrolling, almost like a heartbeat monitor, which is why it's called that. So as the SWR changes, this bar graph changes. So let's see if I can adjust frequency up and down. We can actually see the SWR changing because I'm changing frequency. So we can tell by looking at this bar graph very quickly if I'm making adjustments in the right direction, either with an antenna tuner or by actually tuning my antenna physically. So it's another easy way to kind of monitor how the changes that you're making to the antenna or your antenna tuner are affecting the SWR. Now, an interesting variation on the single frequency SWR meter is the multi-SWR measurement. We hit the function and 7 key. We look at the multi-SWR measurement. Now, this is allowing us to look at SWR measurements on multiple frequencies essentially at the same time. Now, we can see in this case, I've got a single band antenna, so I've got good SWR on the 20 meter band, but very bad SWR on all the others. But if we were looking at a multi-band antenna, like a trap dipole or a multi-band vertical, oftentimes when you're making adjustments on one band, it will affect the other bands slightly. So this will allow you to kind of see the effect on all of the bands as you're making band-specific adjustments on that antenna. Very handy feature. So in addition to this numeric mode for the multi-SWR, we'll also see that there's a graph mode that's entered by hitting the function and up key. So we go and hit the function up and hit OK to run. We essentially get a little graph of each one. So instead of actually looking at the numbers, you can actually see what the SWR sweep is doing in each of those particular bands. Of course, you've got the ability, no matter which mode you're in here, to make adjustments to what frequency it is that you're looking at on each of those bands. And finally, the all function, character or key number 8, will allow me to actually get live measurements of SWR, complex impedance and phase, return loss, as well as the complex impedance and the capacitive and inductive components measured kind of live. And again, we can adjust frequency and watch those things change. So as we've seen, this is a very comprehensive analyzer for looking at antenna mismatch and SWR conditions, complex impedance conditions for both swept as well as fixed and multi-frequencies. Very handy analyzer. Let's take a look at some of the other tools for doing some measurements on coax. Next, we'll take a look at some of the coax measurement tools that we have. If we hit OK under Tools, the first one is the Stub Tuner. This tool allows us to determine the half wavelength and quarter wavelength lengths of coax. If I hit OK on this, it tells me to connect the cable with an open or short at the far end and then press the check mark to start. So I've got this hunk of cable here that's open at the far end. And what it's telling me is that this hunk of cable is a quarter wavelength long at a frequency of 5.24 megahertz, and it's a half wavelength long at 12.6 megahertz. And again, these could be handy values because what we know from coax is that, or transmission lines, is that if you use a half wavelength at a given frequency, the impedance seen at the feed point of the coax is exactly the same as the feed point or the impedance that is present at the far end. The quarter wavelength moves us halfway around the Smith chart, essentially gives us the complex or the inverse of the impedance. So this very easily allows us to determine quarter wave and half wavelength lengths of coax. The next tool allows us to determine either the length or velocity factor. If you know one, you can determine the other. So in our case here, we know the velocity factor of this coax is 0.66, but I don't know the length. So I'll hit the check mark here to go measure the length. And it actually measures that length of 24.87. In this case, it's feet, because I've set the analyzer to use imperial units, because that's what I use here in the US. But you could also set it to measure in meters. Now, if you knew the length, but you didn't know the velocity factor, you could dial in the length and actually measure the velocity factor. Now, the cable loss tool allows us to measure the loss of the coax versus frequency. We start off by leaving the far end open and hit the check mark. It collects a little bit of data. Then it's going to ask us to connect up a short to the far end of the cable, which I'm doing now, and hit the OK key. Oops, hold on, let me get my short on there. Hit the OK key. We'll make some measurements on the short. And then we get the plot of loss versus frequency, and we can move our frequency back and forth to measure loss at any given frequency here. And once we've done that sweep, we can also then switch to the cable impedance tool and hit OK, and we've automatically got the results of that. That's going to show us our coax impedance versus frequency. Now, in this case, you're going to see these little disturbances that are going to occur every quarter wavelength, just because of the way the impedance inverts at the quarter wavelength boundaries. But we can see that this coax is a little bit closer to 55 or 60 ohms as opposed to 50 ohms. This is an old piece of dried out coax here, so I'm not too surprised that it's not closer to 50 ohms, but very easy to get those results as well. Let's talk a little bit about
Bom, para quem não sabe, esse foi o primeiro encontro de Biúna, agora domingo passado, ok? Essa gravação foi da live, ok? Eles começaram às 7 horas, né? E a live se estendeu, né, durante todo domingo, ok? De 7 horas de transmissão ao vivo lá de Biúna. Essa já era, acho que era do almoço. 7, 8, 9, 10, não. Do almoço aqui, ó. Tem mais amigos. Aqui já eram umas 11 horas. É isso aí. Para quem não sabe, esse foi o primeiro encontro de radioamadores de Biúna, ok?
Roupa com resíduos?
Solutan 3906 para o táxi.
3906, aguarde táxi. Papa Romeo Delta, Eco.
Serra Delta, Whisky Serra para Serra Delta, Papa Romeo Bravo 3. Está ingressando pelo Pacaembu.
Papa Romeo Delta, Eco Bravo, juízo no 014, acione transponder 0101, está autorizado a prosseguir para Pouso Central 3, reporte na...
Bravo, 0101, uma cruzará final para o Bravo 3.
Uma aeronave vai alinhar, o senhor ingressa na Lima e informa que o último bug da Gol, agora aqui na Lima, vai ceder passagem ao senhor. Guardar.
Paulo, São 3056-02, posicionamento. 101, idêntico.
2189, ingresse Mike para o 01.
Mike 01.
3056, a posição é a 02.
Afirma.
Gente, aguarde push.
Aguarda.
O Papa Romeo Delta Eco Bravo, você já está prosseguindo para o Central 3, confirme.
Pousando no Central 3 no momento. Solo 3906 para o táxi, passa a bola para o táxi.
3906. Táxi via X-Way e Mike mantendo a retaguarda do Boeing da Gol na Lima.
X-Way, Mike, retaguarda do Boeing da Gol na Lima, Altan 3906.
3906 corrigindo. X-Way Lima mantendo a posição retaguarda do Boeing da Gol.
X-Way Lima, Altan 3906.
E após a passagem do R2, Embraer que pousa, a linha mantém 3 esquerda.
Após Embraer, final, e aí manter 35 esquerda, tá? 3132.
Retorno 27 desse modo.
Serra, direito, monitor, 1, 2, ponte da rede. 206, para posicionamento.
Aguarde estimado de 5 minutos, o 2606. O Bravo informa que a aeronave da Lacerda vai alinhar, aí o senhor prossegue para cima.
Paulo, Papa Romeu, Papa Charlie Hotel.
Papa Romeu, Papa Charlie Hotel, o senhor é o próximo na sequência para acionamento? Aguarde mais uns 2 minutos.
Guardando Papa Charlie Hotel, grato pelo update.
Azul 400, no meio, solas 12, livre à esquerda, ingresso Mike, 1219, tem bom dia.
Na Mike, 1219, o Azul 400, bom dia. São Paulo, bom dia, 3703, estabilizado Vitor, 35 esquerda.
Então, 3703, bom dia, continue a aproximação 35 esquerda, juízo no 014, aguarde a pista livre.
No 014, aguardando a pista livre, 3703. Confirmar a pista, tá molhada?
Afirmo, pista molhada.
Obrigado. Delta Eco Bravo no Pacaembu.
0100 coordena.
Bom dia.
Então, 3138, vento 010 graus, 10 nós, autorizado a decolagem 35 esquerda, após controle 119, decimal 6.
Classe 3 horas, está 3138, modificado 19,6 após. Bom dia.
O senhor está visual com o mesmo, se movimentando?
Afirmo, gol no 458.
Após o mesmo, continue seu táxi via Lima e no ponto de espera monitora a torre no 27 decimal no 5, gol no 458.
Após tráfego líder, segue monitora a torre 2715, gol no 458.
3906, prossiga a retaguarda do Boeing da Gol e no ponto de espera monitora a torre no 27 decimal no 5.
Na retaguarda da Gol, no ponto de espera 2715, na 3906, bom dia.
Bom dia. Papai Charlie Hotel, autorizado acionamento, chame táxi, registro no 014.
No 014, autorizado acionamento, vou chamar para o táxi, Charlie Hotel 4.
Paulo, São Paulo, bom dia, é o Tango Papa Alfa.
Tango Papa Alfa.
E na autorização de reboque do Marília 2 para o box 28.
Tráfego à frente, curva oposta, vento norte 10 nós, autorizado deve 35 esquerda, após controle 120 decimal 45.
Autorizado decolagem 35 esquerda, após controle 2045, 36, 34.
Vou no 444, ali mantém 35 esquerda.
Ali mantém 35 esquerda, vou no 444.
Então 3703, continua a aproximação, gás está livre, só vai aguardar uma decolagem.
Aguardando 3703.
E o Embraer da Azul parquear no 03, está autorizado pushback Swr Meter, ajuste no 014.
Afirmativo, após o azul, parqueando no 03, está autorizado, chamar o próprio táxi da 3056.
O Azul 2606, pushback estacionamento autorizado de Meter, ajuste no 014.
O 04 autorizado pushback para o 2606, chamar o próprio táxi.
Alinhar autorizada decolagem 35 esquerda, vento norte 12 nós, pós controle 119 decimal meia.
Está livre alinhar e decolar, 35 esquerda, 19,5 controle após, voo 444.
3074, aguarde.
Guarda. São Paulo é o gol 1-1-38, pushback estacionamento, posição 1-0.
Nuno 38, mantenha a escuta aguardando.
Guardando, 1-3. Gol 35 esquerda, está 3703. Bom dia, gol no 300.
300.
Canal 9 para pushback estacionamento.
Aguarde, estimado de 5 minutos.
5 minutos, obrigado. Controle São Paulo, Ouro 444, bom dia.
Autorizado de Sanitário, ajuste no 014. Coordene com a equipe solo para não interferir com o gate 07.
Chamo, autorizado pushback estacionamento, pista 35, vai coordenar com a equipe de solo para não interferir no 07, da 3074.
Romeu, uniforme Mike, vento norte 12 nós, autorizado a decolagem 35 direita, pós controle 119 decimal meia.
Decolagem 35 direita, pós controle.
Papa Romeu Bravo, Bravo Delta, bom dia, Lima, mantém 35 esquerda. Então 3703, Paulo Zona Centro, livre à esquerda, ingresso Mike, Soleno 219, vem, bom dia.
Esquerda Mike 219, só 3703. Para o táxi.
Azul 2606, táxi via Whisky Lima, ponto espera 35 esquerda, monitore torre no 27 decimal no 5.
Whisky Lima, ponto espera para 35, pessoal 2 metros no 5 dos 2 metros. Então, bom dia, 3703, livrou Mike.
3703, Mike 07.
Mike 07. Paulo, Papá Romeu, Papá Charlie Hotel, acionado no hangar da líder, 5 a bordo, 4h30 de autonomia alterna Galeão, instruções táxi.
Papá Romeu, Papá Charlie Hotel, táxi Lima, ponto espera 35 esquerda, monitore torre no 27 decimal no 5.
E táxi via Lima, ponto espera 35 esquerda, monitore 2715, torre Papá Charlie Hotel, grato. Paulo, tá 3074, pronto para o táxi. Na escuta do 2606.
Azul 2606 vai ceder passagem ao tráfego saindo do pátio da líder, o último pátio à sua direita.
Pátio da líder, na passagem 3074 para o táxi.
3074, aguardando companhia à sua esquerda, que ingressa no 07, após taxi via Mike e Lima, ponto espera 35 esquerda, monitore torre no 27 decimal no 5.
Companhia ingressar no 07, táxi autorizado via Mike Lima, ponto espera vai monitorar torre 127 no 5, tá 3074. Volta 3056, instruções de táxi.
50 passando o Cebolão de Serra Oscar Vitor para Serra Juliette. X-Ray Kilo no Central 4.
Eco Bravo Romeu, transponder 01 no 01 no 0 no 4, autorizado a prosseguir para o Central 4, reporte na final dele.
101 autorizado Central 4, Bravo Romeu.
É o Tango Papa Alfa, calçado no 28, ligar a frequência, 1 Bia.